if x of t equals e to the t plus 3 and y of t equals 2 to e to the t plus 5, find the arc length for 0 less than or equal to t less than or equal to 1. Okay? So this goes to our arc length formula. So the arc length formula, so I always think of, you have your arc, you have your dx, you have your dy. Therefore, this length here will be dx squared plus dy squared, square rooted. And so our arc length formula will be dx squared plus dy squared. This is more mnemonic than fact proof, but it is useful and it keeps me from making silly mistakes that I don't have to make. Which then gives us dx squared square rooted 1 plus delta y delta x quantity squared, which then simplifies to the actual formula, which you probably have memorized. But if you don't, that's fine too. dy dx squared dx. Okay, so what we first need to find is we need to find dy dx, and then we need to find dy dx squared. But to find dy dx, we need to use parametric equations because we're not given y in terms of x or x in terms of y. So the easiest way to do this is another, I guess, mnemonic. We have dy dt over dx dt equals dy dt times dt dx. Dividing by fractions, you multiply by the reciprocal. Cancel, cancel, equals dy dx. And so we need to find so we'll find dy dt, dx dt, and divide them by each other, and that'll give us dy dx. I know, it feels like a lot of steps. It's not that bad. At least I hope not. We shall see. All right, so dy dt equals 2e to the t plus 5. So we got derivative of 2e to the t plus 5. I'll just do this. dy dt equals 2e to the t. That isn't too bad. dx dt, because the 5 goes away with the derivative. E to the t stays e to the t, and then 2 is a constant, and it just stays the way it is. dx dt goes to e to the t. So dy dt over dx, a little bit more real estate, there we go. dx dt equals, this will be easy, 2e to the t over e to the t, which equals 2. Got it. So dy dx equals 2. And dy dx squared equals 4. Seems like this is coming together a lot easier than I would have expected. Maybe. We'll see. Okay, this might be. We'll write things out and see what happens. Okay, so we have our equation here. Integral of 1 plus 4 square rooted dx. So the trick here is we now have dx, but we want to do things in terms of t. So we want to find out what dx equals. So we have this over here, and therefore we can say that dx equals e to the t dt. So doing some substitutions, we have integral square root of 5 e to the t dt. Move out the square root of 5. Put in the 0 to 1 is what we're integrating from. E to the t dt. This equals square root of 5 times, make a bracket here, do an e to the t, because the integral of e to the t will just be e to the t. We'll integrate from 1 to 0, another bracket. Probably should have done parentheses. And this will give us, when we evaluate it, square root of 5 times e to the first, which will be e, minus e to the 0, which will be 1. So we have square root of 5 e minus 1. Yeah, I'm good with that. All right, so copy this, move it over, rotate so it's straight because I'm incredibly right-handed. And looks like it's the top one. Oh, that worked out well. Huzzah. Hop, hop, hop. Yes, top one. So the idea with this one is nothing here is hard, but there's lots of small things that kind of jump out. So arc length is kind of unusual. You don't deal with it a whole lot. And so the trick for that is to to know the formula. And the way I know the formula is I look at, all right, you have a curve and you do the Pythagorean theorem. X squared plus y squared square rooted for the hypotenuse. Take the integral of that. You factor out the delta x. That becomes the dx. And you're left with this equation for your arc length. Well, you have parametric equations, so you have to find dy dx using dy dt dx dt. And that's not hard, but it does take, you should do it a couple times in life. So what you do is you divide two fractions, which is multiplying by the reciprocal, and you find your dy dx. Now, you write it all out, and you're left with this dx. But you're like, okay, everything here is in terms of t. What do I do with this dx? Well, you already have your dx dt over here. And I know this isn't entirely kosher in life, but it works, and it's reasonably correct. You can take your dx, and you say that, all right, dx equals e to the t dt. You just move your dt over. So you're left with this, and you substitute in e to the t dt over here. And now you have everything you need to solve for the integral. You evaluate the integral, you get an answer, move on with life. And that is how you do arc lengths using a parametric curve and parametric equations.